on the handsome and one that was like used for real estate. Yeah. This is actually tomorrow, like, there's a local like person that actually.
Yeah, I was thinking about that.
I guess I should get started.
Yeah, good.
Okay. Hey everyone, thanks for coming out. Title of my talk is Test-Driven Sitecore. And it's the second test-driven Sitecore talk we have today, so realizing we can do kind of A/B testing between two of them. Which is a good point. This is not about A/B testing or multivariate testing. This is about unit testing and test-driven development. Just a quick introduction of myself. My name is Dan Solovey. I'm a Sitecore MVP, lead architect at Exantium. I've been doing Sitecore for about 6 years, and I've been interested in test-driven development for actually a little bit longer than that. I had as part of a web standards committee a while back, a couple of companies ago, and I had the job of researching developer testing best practices. And I came across a whole paragraph about executable documentation. And the person writing got really excited. He said, this is documentation you know is accurate because you can run it and you can see it pass, unlike everything else you work with. So that really stuck with me. Didn't really become something that was part of my day-to-day way I did development until about the last 3 years, I'd say. And it's not something I do all the time. It's something I work in. But I have noticed a lot of really good benefits just in the quality of my code and the flexibility of my code. I find that things that I write through this process, I end up being able to use in surprising ways, and it kind of looks after me. So really excited to be able to talk about it today. And the main thing I want to get across is this is something that is practical to do with Sitecore development, and is something that can have a really good effect on the quality, the flexibility, the robustness of the code you're writing. So, things I'm going to cover. I'm going to talk a little bit about what TDD, test-driven development, means, a little bit about where it comes from. I'm going to talk about the question of unit testing versus integration testing. Often those words are used, or unit testing is used to really mean integration testing, and I think that it is an important distinction, particularly for Sitecore, so I want to talk about that a little bit. I've got a slide on my tools, just so if you see, wondering exactly what tools I'm using to run these tests, you'll have a background there. I have one link at the end of my talk, which is a link to a blog post that has all the links. So it's kind of meta, but it should work reasonably well. So after the tools, that kind of sets things up. Then I get to the heart of the talk, which is 3 demos. You get to see me do live coding, so hopefully I'll get all my semicolons in the right place. If not, the test will show that. The 3 demos kind of walk through a progression, which I'll get to in the next slide. First one is Sitecore integration testing. So this is testing where I'm writing tests that actually talk to the Sitecore database. And we're going to actually see items get created in the Sitecore database when the test runs. So that's very tightly wired to Sitecore. The second demo is using FakeDB. Some of you saw also got a look at earlier this morning with another talk. FakeDB is kind of almost, you can call it unit testing unless you want to be really, really pedantic. It's unit testing because you're not actually talking to the Sitecore database anymore. You're talking completely in memory, but you're still talking to, you're still interacting with Sitecore items, and you're interacting with the Sitecore kernel, and your test library even has to have a Sitecore license file. And then my final demo, you really cut the cord completely. You're not talking to Sitecore. You're really not talking, I'm working with GlassMapper, but because I have dependency injection, this is AutoFac in my final demo, we're not even directly talking to Glass. Our code is really working completely in isolation. And then after those 3 demos, I'm just going to wrap up with a couple of thoughts about how to get started with test-driven development, both as an individual developer and as part of a team. So this is just, I just talked about this a little bit. This is the progression I'm trying to show. These methods are getting more and more isolated, where with, losing my mic, with Sitecore integration testing, we're tightly wired. fake to be, we're starting to get separate, but we're still, our code, way we write code hasn't really changed. We're still working with Sitecore items. We're still working with the Sitecore kernel directly in our logic. And then with this glass mapper, and glass is just the ORM, object relational mapper, that I'm used to working with. There are many others out there. There we're really starting to put a layer of separation. And so why is isolation useful? Well, it gives you more flexibility. So this is a really famous image. This is a series illustrating the solid principles. So this is the dependency inversion principle. Is the idea that your business logic doesn't want to have really tight wires to the underlying low-level systems it interacts with. And the idea there, is you wouldn't want to solder in a light bulb, solder in a lamp into a socket, because then you can't pull it out, put something else in, like a more powerful lamp, or move the lamp to where you need it. You're really taking away your options. Another metaphor I find useful is like, you don't want to glue your Lego bricks together. You want to be able to take your Lego bricks apart. And when you write code in such a way that you have the dependencies wired right in, you are really kind of gluing yourself. The more dependencies you take into the code you write, the more you are limiting your options for changing things. So that's kind of the incentive for moving up that progression towards a more isolated way of writing code. So, test-driven development, where does this come from? So it originally comes out of, who here is familiar with extreme programming? Okay, so about 3/4 of the room. So this is a methodology that was put together by this guy, Kent Beck. Really interesting story. He was brought on as a small talk consultant onto a project, and he couldn't believe how bad the code was. It was like just written by people that obviously never spoke to each other. And when he came on site, he saw that the layout of the floor, there were these 4 corner offices, and the 4 senior developers grabbed a corner office and never talked to each other. So this is all in, he talks about this in the book, Extreme Programming, Embracing Change, whatever the title of it is. I have a link to it. Anyway, first thing he did is he gets them all into one room. You guys are coding together. This is where all the coding is going to happen. He starts pair programming, so everything you write, you're going to be writing, interacting directly with the other developers. And he gets the person who is the owner of the project down, working directly with the developers, so the customer is not part of the team. And all of those things are about giving really quick feedback, so you know if you're going off the rails. And so you're able to change directions quickly because you're getting a lot of feedback that yes, things are still working, or no, we need to make changes. So part of that is having every single piece of code, every single bit of delivered functionality covered by a test, so that if you need to change things, you know very quickly whether you've changed things in a way that still works. And then he wrote a test runner, and while he was, so this is a tool that runs tests, and while he was working on that, he read a little bit about the early days of programming, when it would cost, we're talking 1950s, you did not get to run programs every couple of seconds. You got a chance to run your program, and then you waited a week to get your next turn. And so you really had to get it right very, very quickly. And in this book, he read that the way things were done is that you would actually figure out by hand every single, you come up with a really detailed test suite so that you knew your logic was sound. And he thought, what if we did that in a situation where you didn't have to wait a week to run the code again, but you could do it in a second? What kind of result does that get? Well, one thing, if you're writing the test first and then you're running the code, you're writing tests. You're getting a continuous buildup of feedback. So this is where he really gets this idea of writing a failing test and then running code to pass the test. And he shares that with another person who was very important in the Agile movement. This guy, Robert Martin, Uncle Bob, sometimes called author of the solid principles. We just saw a slide on the D in solid, dependency inversion principle. He was originally very skeptical about this because it sounded like a bit of a waste of time. And then as he started to work with it, it just totally changed the way he programmed to the point where he couldn't imagine not working with it. He has a really nice essay, which I'll show a link to at the end of the talk, where he says, the days where I would take something apart and not know whether it would work again for another 5 hours are behind me. I never want to be in a situation where I can't immediately know that everything's working. And the reason why that's important is because that lets you change your code. That lets you play with it, shape it, And so if you are trying, I think the relationship to solve is really important here. If you're trying to push your code to a more flexible, more decoupled, more robust place, you're shaping it, you're working with it, you're finding pain points, and you're staying out of that zone of, oh my God, it's working, I don't want to touch it because I'm probably going to break it. You're, well, no, I can touch it, I can play with it because I have this constant feedback that everything's working. So that's a little bit of where it comes from. Now let's talk about what it is. So there's a standard cycle, the red-green refactor cycle. I want to talk you through it a little bit. So red, the color red comes from what you get on a test, one of these tools that run tests. If the test fails, you get a little red light. So the idea here is before you write code, before you change the system, you think of something the system doesn't do that you want it to do, and you write a test that shows it doesn't do that. And the test is very minimal. I like to have this class, well, the class doesn't exist, well, that's a failed test, it doesn't compile. Whereas class will have a method, or when I put the values into the method, I should get this result back. And you can work in really small chunks. And it's really important you're not trying to think of everything at once. You're picking just one thing that you're going to start with. And you get a test showing that that doesn't happen. And then you write just enough code to get that test to pass. And it's really important that you be very lazy here. There's a line that Roy Osherov, who has been very active in the test-driven development community as a lecturer and worked at Typemock, which is one of the big software companies involved in this. He has this line I love. He said, you want to pass a test as if it's 4:55 p.m. and you want to leave at 5 o'clock, or like your 11-year-old cousin would. And the idea here is that you just want to get to green. You don't want to sit there and say, oh, do I need a caching layer? Or do I need to do this? Or really should I be pulling this into a separate class? Or maybe I want to be writing a new language? You just, no, just get the thing working. Now, after you have all your tests working, you can say, you know, I probably don't want to copy that code. You know, maybe I can move this into a shared method, or maybe, you know, this controller method is getting 600 lines long. I think I want to start breaking it up. Or, you know, I just want to rename a variable because the variable name doesn't make any sense. But you think about the design when you have everything working. And so the power of this is that you're dividing up your brain into very specific actions. You've got requirements brain that says, I need a class that can add these things. You've got implementer brain, so I could just do this to get it working. And then you have architect brain that comes in and says, well, you know, actually it makes more sense if I did it this way. And you move through these states really quickly. So the cycle is about 30 seconds, 45 seconds. Write a test, get the pass, take a look, write a test. And by breaking the problem up into these little chunks, you kind of get at least I find, I get a much higher level of concentration on each one. You know, I'm not getting distracted by the fact I have to do 5 things, I'm only thinking about one of them. And when I'm getting it working, I'm not thinking about the perfect way of getting it working. I'm just getting it to work. And then with the refactor, that's, you know, once I have everything working, I can kind of take a breath and say, huh, is this really what I want to do? And then, you know, another way I like to look at this cycle is kind of you're hungry. You're hungry, that's a red light. You make a sandwich, that's a green light. You wipe down the counter and put the plate in the dishwasher so the kitchen doesn't become disgusting for the next developer, that's the refactor step. You can divide those up and move through that cycle. Okay, so that's TDD in a nutshell. Unit and integration testing. Who here is familiar with this distinction? Okay, about half through. So I mentioned this guy, he's the author of that 11-year-old cousin analogy I like so much. He has a really classic description of a unit test. I'm just going to go through it pretty quickly. Few points, it's automated. So if you run your test by going to the home page and seeing that it looks okay, that's very important, but that's not a unit test. Second of all is really important. It runs in memory. It has full control of what's going on. So if you have, let's say, a different message that shows up after 5 p.m., or on February 29th, and you have to test it, you have to change your system clock, you know, 5:01, then change it back, and I've done that. But if you're doing that, you don't have a unit test. If you have to call a web service, you don't have unit test. If you have to call a web service at the client side over VPN that hits a database that has to have a record in the test database, not a unit test. Unit test has complete control over what's happening. Because it has complete control over what's happening, it's always going to give you the same result, and it's going to give it to you really, really quickly because it's happening in memory. And the way you do that, you still have to talk to web services and go over VPN and read the system time, but you're putting abstractions in place. You're putting interfaces or abstract classes, and you can use tools, and we'll look at those tools later on in the talk, that basically shape the behavior of that in your test. So you can create kind of an alternative reality where it is after 5 p.m. every time, or it's before 5 p.m., and you can basically isolate those bits of reality from your test so that your tests have total control. Other important points, test a single logical concept. This is really, really important. This is very easy to get wrong. You write a test, and you say, these 15 things have to be true. And that's great. If it passes, you're like, I know that all 15 things are true, and that's awesome. But then if something goes wrong, you have absolutely no idea what went wrong. You did test. All the things have to be right. Make all the things correct. That's no longer true. You now have to debug and figure out, like, oh, well, this turns out this one was wrong, and oh, these ones never even executed. You don't have a lot of actionable information. If you took that and made 10 separate tests, and number 3 failed and number 8 failed, and each one was testing exactly one thing, then just from the names of the tests, if they're well named, you know exactly what's broken. And that gets the idea that if the tests are just covering one thing, they should be very easy to read and understand. They are documentation. They are showing how the system works. They are production code. And that makes them more maintainable. And then you get to this idea of trustworthiness, which is really key to the concept of a unit test. They should always pass. The fact that they're always passing should give you confidence that things are good, that your system is in a good state. If something breaks, if something fails, then you should be thinking that something is seriously wrong. So they don't cry wolf. Contrast that with integration tasks, where you do go over VPN to the client's integration test server, that you hit the database that has the test record. They're more fragile. On the other hand, they show that real stuff is happening. They're showing that the order is being created. They're showing that the pieces do fit together. So you want both, but you want to know which is which. So one recommendation Roy Osheroff has is you have 2 different projects. You have a unit test project, you have an integration test project, and you just keep them separately. And the unit test project should always pass. Integration test, you expect a little bit more sensitivity. Okay, so my tool slide. So NUnit's most common. Who here's worked with XUnit? Okay, so XUnit is catching on. XUnit was actually built by the person that wrote NUnit and realized it was too late to change. And it's used currently, for example, by Microsoft's ASP.NET development team. If you looked on GitHub at their latest code, they're using XUnit. And really the major benefit I understand is that every time you run a test method, it creates an object. And then after the test method runs, it disposes it. Then it creates a new object, runs that second test, disposes it. So it's much harder to get side effects between your tests. The way NUnit and the other systems typically work, you create a class, you run a setup method, then you run one method and another, and it's much, if you're careful, you won't have side effects, but it's not looking after you the same way. And the guy who wrote NUnit said, I got that wrong, and I can't change it now. So I've heard someone say there's a new version that goes, I don't know. There's that may be getting fixed in the latest version of NUnit, but XUnit has really gotten a very wide acceptance. So you'll see, instead of test, you'll see fact. That's because I'm using that. Ncrunch. So Ncrunch is kind of like the crack cocaine of test runners. It runs the tests while you type. It's IntelliSense. So you're literally writing the test, and in a low priority background thread, it's copying the tests over to another directory and running them, so you actually get feedback without even saving the file. If you use Ncrunch a lot, you often find that you actually haven't saved a whole bunch of stuff. You've just sort of written code and written tests, and it's all got the little asterisk next to it. And this whole process is around feedback, so this is something that really can put people on it. You'll get to see that. And substitute, I talked about. how we're creating interfaces and we're talking to interfaces, and Substitute has the job of making fake versions of those interfaces. And it creates fake versions, and you can tell those fake versions how to behave. First of all, if you don't tell them to do anything, they'll do reasonably obvious things like return 0 for a number value or date time minimum. And so you don't have to babysit them a lot, but you can say, hey, I want to return current time as being 6 p.m. Or I want to be able to check whether a method got called. There's a, NSubstitute is a more recent one. There's mockq, there's rhinomox. This has a really clean syntax, really good error messages, and it doesn't let you do things that are generally widely considered to be a very bad idea that some of the other older frameworks use. And the documentation is superb, so I definitely recommend taking a look at it. And this is not part of the tests. This is what makes the stuff work in production. So when you actually hit the page, you need something that says, oh, I've got this interface, I need to put a real object in there. AutoFac is one of many dependency injection containers, and that has a job of basically stitching all your stuff together. You have a short little class that you write that runs at application start, and basically says, oh, when something asks for this interface, stick this in. And basically, you set that up, maybe with some good naming conventions, and you can kind of forget about it. And then the rest of the time you're doing your development, you're always talking interfaces. Okay, demo time, and I'm right on schedule. Okay, so the first one is integration testing. A little bit of background about this. Sitecore integration testing means we're talking to Sitecore. It means we're creating items and we're checking, maybe renaming them. There are two big approaches here. First one was originally recommended by Alistair Denny's, former MVP, now works at Sitecore, and he was working on the Revolver command line tool. Basically like the Sitecore PowerShell extensions, it gives you a command line to interact with Sitecore, and he wanted to have a way of making sure that it worked for different versions, and after he made changes, and avoid chasing his tail, basically he wrote a bunch of tests. To run those tests, he wrote a browser tool that runs end unit tests inside the browser. So the advantage of that approach is that you're speaking Sitecore's native language. It's happening inside of a web request. The guy who wrote Glass, Mike Edwards, figured out you could also run tests directly from a class library. I know Mike, and he's a huge fan of nCrunch, so I think he liked having that immediate, I know he liked having that immediate feedback, which you wouldn't have with a browser. It is a somewhat more fragile approach because you're kind of running Sitecore without a browser, without a web request, so it's a little bit of smoke and mirrors aspect to it, but I'm going to show you there you can use this approach to interact with Sitecore and to develop code that interacts with Sitecore. So let's get to that. This is integration testing, great. So a little bit of background on this. I'm not going to go through everything that's involved to wire this together, but I have a little build script, like after build, that is copying the entire app config hierarchy and the entire bin directory from Sitecore. And I tried picking specific things, and I would run into one bucket after another, and it just seemed simpler to pull them all in. And there's a build script that actually Alistair Denny's proposed, and I made a couple of tweaks to, and I think I have a link to it in my big links blog post. The one other thing you need to do is that if you don't set this up, this little line right here, state HTTP runtime app domain app path, set it to the current directory. If you don't do that, then it's going to look for all your app configs in C:/, and it's Dan Cruikshank that found that. It's really kind of cute. Once you have that, you have the ability to interact directly with Sitecore. So right now we're trying to get the Sitecore database, and we can kind of confirm that this is really happening because we could just change the name. And that should turn red in about a second. So yeah, so now it's no longer able to get it. So we have communication with Sitecore, which means we can now start building some functionality. So just to give a quick little demo example, suppose I wanted to build something that created items. So when my created test, it says, I'm gonna look at this screen, that's gonna be a lot easier, won't it? Okay, so we've got our fact here. Void item creator. Returns valid ID. Okay, so the nice thing about this kind of approach is that you kind of use this test class as kind of a whiteboard to think about, okay, how do I want this thing to work? Well, I'm gonna need what I want it to look like, and you kind of can just start sketching things out the way you would with a pen on a whiteboard. So I'm gonna have this, my item creator equals new item creator. Okay. And this technique works really well with your sharper because whenever you see anything red, you can just go Alt-Enter. And I like to kind of create my classes as I'm building them using this technique. I like to create them right there inside the class library until I kind of feel that they have enough functionality and I've got enough tests that they do what I want. And then I kind of push them off to the other DLL, kind of like pushing the bird out of the nest because it now knows how to fly. So I've got that. It's not yet ready to fly that yet. I think we want something backhand, maybe return an ID. Item creator, create item. And I'm kind of using this to think about what I want it to look like. I think I probably want to have a name. And I'm going to need a parent item. Excuse me as I fight with IntelliSense. And I'm gonna need a template. So let's just say we could think about this, we went to full path. Nah, we probably want just a relative path of the template. So this ships with every default installed Sitecore. Okay, and that parent, and I steal from my own tests very liberally. Though at some point, you have that refactor step to say, I maybe want to group this together. But right now, this is pretty expressive if I just do that. So I'm happy with it. And that's the bottom line for me. Different people have different opinions. I want the test to really explain what's going on. If you could look at it and read it in one kind of paragraph and say, it's setting up this, then it's running this, and then this is what happens, I'm happy. And if I don't keep hitting return when I don't need to. Okay, so we've got, now we have what we're passing in, but we don't yet have the method, so I'm just going to Alt-Enter into existence. Okay. And I must be missing something here. Why isn't this running? Joys of working with a very large font type or namespace definition and a file expected, so I'm missing a semicolon. Okay. Go like that. Okay, and it's failing. Well, it's failing. Okay, is that our failing test? Well, it's failing because it's throwing an exception, which is kind of not really useful for validating that our test is legitimate. So why don't we just return ID null. And the reason why that's useful is that's going to pass, and that'll get us to a failing test, because we want to get to a legitimate failing test. So I think a good failing test would be assert, not null, db, get item, ID. Give nCrunch much a chance to run that. Boom, that fails. Okay, so now we get to channel our 11-year-old cousin. Okay, simplest way of returning this. Return 11-year-old cousin, or you're doing a demo and you want to get it working. That would probably be parent, add, name, and then new, and ReSharper or Villager Studio is giving us some useful options here. Template, and we'll just go parent, DB, add, no, get item. Sitecore, templates. What's this thing called? Sample. So this guy who wrote XUnit says he always uses really bad names when he's writing his tests, so that he always has something to refactor. Okay. And it's green. Well, that's pretty cool. So, well, I think an obvious thing that we could refactor here is call this template path. And it should still be green. And just wrap this one up. I want to show you that I closed my browser. TDD, demo 1, Sitecore, log in. Okay, audience participation time in a second. We see stuff here. What would be a really cool item name? Monkey. Thank you. And now you get a button. Okay, so let's go to our test. And we'll just, I don't think this makes the test more readable or usable, but M-O-N-K-E-Y. We're doing spelling and live coding because who can always use more pressure. Monkey! Awesome. Okay, so this is great because if you're really into TDD and you want to see that you are actually interacting with Sitecore, then you can do this. But you are creating monkeys under the home item. You're probably going to want to delete the monkeys under the home item. But you probably want to be very careful with the monkey deletion code that you don't delete, let's say, your templates folder. So you've got a lot of wires here. Personally, I've used this, and at some point I installed Social Connected in my project, and then it stopped working. I never figured out exactly why. It's a blog post for 2020 or something, but the fragility thing, really, I didn't get a lot of value. And it's also not making my code a lot better, so I'm not a huge fan, but it's really good to know it's there, particularly if you're writing tooling. If you're writing something that actually is something that is supposed to make direct actions on Sitecore, and you want to make sure it's happening the way you expect it to, this is a very useful technique. But it is creating monkeys.
Whole barrel.
Whole barrel monkeys. So that gets us to our next approach, Sitecore Fake DB. So this was, I see if I can pronounce this correctly, developed by Sergey Shuzlyapin of Sitecore Ukraine. He's a tech lead there. And I think is Pavel in the room? So someone at BrainJox has also made a lot of contributions to this. And it's a really clever idea. Basically, it's leveraging the fact that there's an abstraction layer underneath item that you can have items because of data providers. You can have them pull in all kinds of other sources of data and have them appear as items. So what this team has come up with is a way of basically, with a very concise syntax I'll show you in a minute, creating an item tree just right inside your test. That's the only thing that's fake. Everything else, you're talking to Sitecore kernel. You're really talking with mainline Sitecore code. So you don't have to change. You don't have to take up working with Glass or synthesis or whatever your ORM of choice is, you can just keep doing things the way you did and still test it until your license file expires and then your test will work. But so you still have connections, but you really are getting pretty. You're no longer creating monkeys under the home item. I don't think you can put any better than that. So let's go to our demo there. Okay, and let's see if I can actually open Visual Studio, fake DB demo. I watched a course on giving talks, and they said, try not to mutter things to yourself that are not relevant to your audience, and it's really hard to do, but I will make a better effort. Okay, font is a little small. I'm going to bump this up a bit. Okay, so this is using FakeDB, and this is code I copied directly. I fixed the tabbing a little bit, but this is code I copied from their documentation, which is really quite good. And basically, this is the idea. You have your using statement. I'm trying to avoid pointing to my monitor. I'll point with my mouse. You have your using statement right here. And inside this using statement, you create this fake DB. And then you create an item. And this is using collection initializers, so it's a really clean syntax. You create your item. And then you create a collection of fields. And it's just a key value pair, the name of the field and the value of the field. And that allows you to now do things like DB get item and look for it. And we're creating this name, so if I change this to, let's say Ray, it'll fail because it is no longer finding Sitecore content home. So you have complete control here. So just to show a quick little demo of what, I'm going to shorten my demo because I'm running a little bit behind. I wanted so the full demo is starting to build out a little cascade tool where you check a field if it's available on, if a field value is available on a current item, then use it, and if it's not available on that item, it's empty, then go up to the parent. And I had one that was completely recursive, but that demo takes like 25 minutes, so we're not going to do that one. But we're going to, and I really do like channeling that whole 11-year-old cousin thing to get myself started. Try to get to a failing test as fast as you can. So it's called fallback field, value, present. And this is a pretty standard syntax for tests. The thing you're testing, the situation, and what you expect to have happen. So we're going to call this some item. And I like having really obvious fields so the person knows exactly what's going on, who reads the test later on. And just to make sure that everything is fine, that should pass, good. I'm going to do a very quick refactor step here so I don't get confused. And we're going to create our fallback field thing. Equals new fallback field. And yeah, this is, again, we get that idea of the whole whiteboard. Like, do I want to pass in the item that I'm going to look at in the constructor? I want to pass in the method. You can try one, see what it feels like, look at it. And you're really kind of creating the API you're going to consume before you implement it. Alt-Enter. Okay, we'll get rid of that. And to get to our failing test, fallback field, let's see, how about value equals get value, assert equal, we expect some value, and then we are going to check it against value. I see we haven't created this yet, so let's create that. And I don't want an enumerable car, I want a string. Thank you. String's good enough for me, but you know, I don't want this phony exception here. I'll just return. Okay, that fails. I have a failing test. Channeling my 11-year-old cousin. I'm going to just alt enter this. And it's not passing. So let's see, I've got 5 minutes on, jeez. Show of hands, who would like to see glass? Who would like to see this complete? Okay, so we're dropping this. Imagine I did something where I got the parent and so forth. You can imagine that. Go into glass now. It's a basic concept here. You've got your controller. And I should show you what I'm working on here. Well, we're going to fix a little bug here. We've got our TDD demo 3 site, which is, you know, your standard bootstrap site. It's got a little bit of lighting up of the current item. But, you know, if you go to SUGCON, it's no longer lit up. What's up with that? Because SUGCON's an event. You know, we're all here. So let's see what's going on with that. So here's the magic I was talking about. This is not your average, everyday, run-of-the-mill controller. This is a super controller because this controller has a constructor that has an interface. And that interface is actually provided by glass, but that is our only connection between this controller and Sitecore. And that is wired together. So if you just put this in without setting anything up, specifically without installing AutoFac and configuring it, you would get an exception. There's no default constructor for this. You know, when you hit the request, you get an error message. So, going a little quickly, I just want to show you the magic that wires this all together, AutoFac config. And I'm going to drill down to one key line here. So conceptually, AutoFac is keeping a big dictionary of interfaces and items. And says, oh, when you ask for an iSitecore item, I know to give iSitecore context, I know to give you a Sitecore context. And that line is registered here. It also knows, oh, I know about all the controllers. So those are all registered here. So you ask for a controller, I will look at the instructor, I see if there are any interfaces I know about. If there are not, I'm going to throw you an exception message. If there is, I'm going to create the real version. And what's great about that is your code is only dealing with this interface, and all the actual wires of Sitecore are over here. And that lets you do the following. In your test project, you can create an alternate reality by doing 2 things. You create a fake Sitecore context using my friend end substitute. And then you can have these methods down here. You can say, set current URL. And with this method, you pass in a string, and then you say, hey, if my fake Sitecore context has the get current item method called on it, and then the URL property called on that, return this URL. Set children of home. If my fake Sitecore context, if someone goes and gets a home item off of it, and these are all methods provided by Glass, and then you go look at the children of it, we want to return this list of child items. So to show you how that's getting used, we'll look at one test. This is a test I used to write the functionality to turn on the little light, to highlight the current item. I create a couple of imaginary children of the home item. I use my friend end substitute to create them. I script what their URLs will be, child 1 and child 2. I then say, hey, set those as the children of the home item. And then I say, hey, let's set the current URL. And yes, this is a product of some refactoring because those methods were all in here and that was sort of duplicated and kind of complicated. And I thought, let me refactor this test so it's more readable. And I think I'm pretty happy with where it is right now because it's pretty clear exactly what's getting set up here. Current URL is child 1. The children of the home item are child 1 and child 2. If we call the controller and we look at the result, we expect the first item to be active and the second item not to be active. Assert is true, assert is false. So that shows why most of it's working, but it doesn't show what happens if we have a grandchild. So my 11-year-old cousin would certainly not write this whole thing again by hand. And he wouldn't refactor until he had his functionality working. So when grandchild is context item, set active. Okay, so we still have the same children, child 1 and child 2. But now we want the current URL to be child 1, grandchild. Pretty clear what's going on here. And if the demo gods are kind, I will see, oh, I'm doing something crazy here. What's going on? Did I blow away why are you red? Oh, because I probably am missing a parenthesis here. Boom. And now that fails. So we have now reproduced the fact that this doesn't work. So now we can go in here, dive in, and it's pretty clear that this get active status needs to be modified. Simplest way to get to a green light starts with. And now it's passing. So if we have child 1 grandchild, child 1 grandchild should, if that starts with this child's URL, then we want this to work. We want to set this to active. So our test shows that that's been created. Then we go to Solution Explorer. First of all, let's go to this, and we see that this is not lit up. And we're just going to publish this. Where's my publish button? Oh,
First quarter.
I think I found it. Okay. Refresh. Come on, demo gods. Be kind. Jeopardy music, anyone? Okay, if I was really efficient, I'd be doing the final slides of my deck right now. It lit up. Yay, okay, thanks. Someone clap, they get a button. Okay, final slides. Okay, so I think you see some potential benefits here. It does encourage focus because you're building one requirement at a time. You are separating out, you're thinking about getting it working and getting it right, and you're keeping this ability to work with your code, to refactor your code, because you have all those green lights on the left, and you're going to see red if you break something. That's going to give you confidence. You're not going to try and get things perfect because you know you can always come back to them. But you will be confident going back to things that feel they do need attention. That 700-line method probably needs to get broken up. And that, of course, drives good design. That's the good part. So it's hard to learn this. It really is quite painful to learn this. And you're going to be sitting here writing these tests, and they're like, what's Dan doing? He's writing those unit test things, you know, and that's, you know, you're learning new habits. You're going to have to find time to do that. So what is my recommendation to this conundrum? Avoid all or nothing thinking. And you know, 1 or 2 hours, buddy up with someone, try some TDD, start, carve off small pieces of it. TDD is a very strict discipline. You know, there's a line, code is read-only without a failing test, but that doesn't mean you have to do it all the time. There's an example I really like. My wife was reading a book called VB6, which is not about Visual Basic. Actually, it was written by a guy who was a restaurant critic, and he was told that he was going to die really soon if he didn't start eating more healthily. And he reviews restaurants that serve very large steaks, and he thought this wasn't really feasible. And then he came with this idea that he would be vegan until 6 p.m. And then he would get the steak and the wine, and I don't know if a cigar was involved, but the healthy part was done. Now was the unhealthy professional career. And his health just improved tremendously. So this has become an expression all the time where people I work with say, Dan, maybe you need to go vegan on this code for a little bit. Pick your spots, pick your battles, pick areas you want to do this, and times you want to do this, and build the skill set. And then to get involvement, just asking for feedback. People love, everyone in this room has an opinion. And if I go up to anyone in this room and says, do you like this? No, it's pretty stupid. Oh, how would you like me to change it? Well, shit, rename that. Oh, you rename it. That person will immediately be your friend. So bring someone over and say, hey, does this test, is this readable? I don't really like the method name. Shouldn't it be returns the value you were looking for when you wrote the test? And you could say that's stupid, or you could say, oh, that's great feedback, let me type it out. And what will happen often is that about 2 weeks later, that person will send you an IM saying, hey, Dan, I'm writing a unit test, can you take a look at it? So, build up, just reach out, get help, show people what you're doing, and be flexible, reasonable about it, and you start to build up interest. I have seen this happen. And the thing that really sells people is when they start working on code that's covered by tests. And then they have to work on code that's not covered by tests. And particularly if you get those green lights going on, they cost a lot, and crunch is expensive. But a colleague of mine said that he was a really big TDD skeptic. Originally he said, I have to work on code and it doesn't have any tests and I'm afraid to touch it. And at that point you got them. And then another thing I found helpful is the TDD kata session. I have a link to that in my big master blog post with all the links. Basically you do a basic exercise, you work together, and you do requirement implementation in a very stepwise manner. And there's even a technique called TDD ping pong. One person writes a test, another person passes it, they write the test. That can be very cool. Finally, sell the value. You're adopting an approach to writing development that is going to allow you to continually make your design better. And you're never going to get to the state of, oh my God, I can't touch this, I don't know what would happen. And that's valuable. That's valuable to your team, that's valuable to your management, that's valuable to your clients. There's an anecdote, I can't mention the name of the client, NDA type stuff, but a colleague of mine saw the same crunch thing. He got his team working on it. He showed it to the client, and they were floored, and they said, we need every one of our developers having this tool. So don't assume that it's going to, you will get some eye rolls, you will also get some people who are going to be very impressed. I'm going to leave with this slide. It's my hero, Uncle Bob. If we have the test, we become fearless about making changes. If we see messy code or an unclean structure, we can clean it without fear. Because of the test, the code becomes malleable again. Because of the test, software becomes soft again. You can keep working with it because you're not afraid to touch it. So that's the talk, that's the Twitter handle, those are the links. Thank you. I've got one button left. But I'll take more questions now. Yes, go ahead.
So with the fake DB, you were creating DB items.
Yep.
Or something like that. If we're using TDS to capture our custom templates and things like that, how does that all work together?
So TDS, so I originally got started on this technique with Glass, where I was using TDS to create my items, and then I would use, and so one thing you can do is you can have TDS return interfaces, where you can manipulate your script and make sure that they are mockable. And it's not crucial they be mocked if you keep, there's a term POCO, plain old C# object. If you keep them lightweight and you know they don't have functionality, you can say, hey, we keep these lightweight and we're just going to stick some stuff in. If there's functionality that's talking to dependencies and you want to isolate it, then that's where you really need to have the ability to wall that off. But I'd say fake DB is mostly because you just don't want to deal with this. You're either don't want to deal with changing the way you write code, or you're in a situation where that's not an option because you're writing a pipeline processor and it needs an item. This gives you a way of getting an item. Still on.
sort of a comment and a question.
Sure.
You were saying ways of selling TDD. Your comment that the quote you had at the very beginning of it's documentation that you can execute. You know it's up to date because you can execute it. That's a huge selling point, in my opinion, of having tests, whether you do TDD or not. You can say you've got docs. If somebody says, "How do I do this?" If your tests are halfway good, there's a test method illustrating how it was intended to be used.
And getting that habit of looking at them, getting the knowledge out that they're there, and someone asks you how to do that, oh, I got a test on, take a look at this. And getting that mindset is very powerful. Totally agree with that.
And then the question is, the examples I've always seen of TDD have always been relatively small, simple, fairly easily contained systems. Take something big and complex. Take, say, Unicorn, designing an entire serialization hierarchy where you have to, to even begin, you have to take into account file formats and hierarchies and essentially write an architecture document. There's not really a spot where you could start from, well, I'm going to make a failing test. How do you do TDD in that kind of situation where it's not a contrived bread box, it's like you have a big, giant problem to solve?
So, interesting question.
I did test after.
Yeah, I would say so part of it is it's a mindset of, well, what would be the first thing that I would get going? First thing I would get, the simplest thing is I could do this, and then you build up incrementally. So it's kind of like trying to push you towards thinking of things as small problems. And I find, I don't know if any of you saw the video that I'd forgotten I had made of me getting very stressed out while coding. It was a simulation, but that often happens in real life, and I find it breaking it apart, saying, what is my test? And it's like, oh, well, I needed to do this. Oh, I got it doing this. Well, I need to do that. Now you're talking about some external thing. Well, let me wall it off. And one example that comes to mind, we had a situation where on a system, someone, I don't remember what happened, they would get an error message or their password would get reset or something bad would happen if there was a serialization error. And I found the whole big serialization error, and my first effort at a test was to take this huge blob of JSON I grabbed during my debug and say, if I pass this in, I don't want this to happen. And I thought, that's really stupid. And I thought, suppose I put an interface and I said my JSON deserializer, and I put that behind an interface. And then I wrote a little end substitute that says, suppose it throws a JSON deserialization error. Then I want to do this. I did that, it fixed a bug, and it made the design more logical. So I hear you, but I mean, the counter argument, and I don't want to be dogmatic about it, but it has been my experience, is it keeps you towards simple. It keeps you thinking. The danger of developers is we all think we're really smart, and we get into this place where we're just writing code and feeling really good. I got this solved and that solved, and then we come back later and we're like, what was I thinking? Or worse, we come back and look at what someone else has written, and this is, the embarrassing thing about TDD is you write like 150 tests for like 7 lines. And there's a line of Robert Martin's that the more specific the tests get, the more general the implementation gets. So I guess that would be the counter argument, is you bite off small pieces and you wall off to things like, oh, something's going on with the file system. Well, you wall that off and it's gonna throw me this error.
Yeah, and that's where I ended up at, like, there were 2 or 3 attempts where I got the major architecture wrong. And if I had started with the small pieces, some of them might have been completely throwaway. Fully tested code, throw in the trash.
And that's
I had some of that anyway.
That's a really good one. I had several slides on the TDD is dead controversy. Who has heard of the TDD is dead controversy? Yeah, and there's 15 minutes gone. But yeah, that's the counter argument, is that this is, the guy who wrote the TDD is dead. The guy who came up with Rails, David Heinemeier, and DHH. Yeah. So DHH wrote this, gave this talk. He said, TDD is dead. Testing is really important, but just don't do a TDD unless you feel like it, but don't feel bad if you don't. Interesting blog post. But he said, he did make that point, that people get so zealous about TDD that they sometimes make bad design decisions. And I think, I think we're all, it's a tool like X unit versus N unit. This is what it looks like when you do it. There are problems that are really susceptible to it. There are really good benefits, like you just mentioned, of getting the executable documentation. But it is pushing you to are like a super solid, decoupled, I'm gonna isolate everything, I've got autofac, I'm always talking to interfaces, I never use datetime now. And I'm like, why can't I use datetime now? Oh, because that's not testable. You know, you get the eye roll there. It's an approach. This is what it looks like. It's worked very well for me. But certainly I can easily envision situations where going that, oh, Kern, dive in, help me out here.
Hi, yeah, so after the discussion.
Oh, no, so I didn't know if you had to, so let me finish my thought on that. I think you have to, you know, your mileage may vary. If you look at it and you think this is not taking me where I want to go, then say, okay, this doesn't look like a good use case, and then write a blog post.